Okay, so we've been discussing planes and we've been discussing lines. These are two sort of objects that we can create that are floating around somewhere in three-dimensional space. Well, we already talked about the case of if we have two lines, do they intersect? Are they skew or are they parallel? Well, we can ask now, what about a line and a plane? How do they behave with each other? Well, this time we actually do only have two choices again. Either the planes intersect, either the plane and the line intersects, or the line is parallel to the plane. There's no third option here. So for this example, here's a line, here's a plane. Let's see, do they intersect? Right? So how do we do this? Well, this problem is actually much, much easier than determining whether two lines intersect even. Because for a plane, we have a nice description as an equation involving x, y, and z. And if we have symmetric equations for a line, parametric equations for a line, or even if we were given the vector equation of a line, it's really easy to get the symmetric. And I did it again. The parametric equations, right? But once we have the parametric equations, notice we know what x, y, and z has to be in order for something to be on the line. So we can just take this x, put it here, this y, put it here, and this z, put it there, and see if we can solve. So in other words, we're sort of plugging the equation for the line into the equation for the plane. Right? This is how you determined whether two things intersected once upon a time. Okay, so let's actually just plug the line into the plane equation. Right? Well, x plus y plus z is 3 plus 3t plus t for the y. So this is the x, this is the y. Z is minus 2 plus 4t. Right? And if it's on the plane, or if that line ever hits the plane, we know that x plus y plus z has to equal 2. Right, so what we're going to do now is simplify this equation here. So we have 3t plus 4t, so that's 8t. And then we have 3, nothing here, minus 2, so that's plus 1, and this has to equal 2. Right? And we can solve for t in this. So this is the same as 8t equals 1 by subtracting this 1 to the other side. And that's t is 1/8. Let's close that 8 up a little nicer there. 1/8. So how do we find the point on the line, or the point that they intersect? Well, we have a nice description of the line in terms of t. So if we plug in that time, t equals 1/8, into the line, we'll see the point on the line that hits the plane. That's the point on the line that satisfies the equation of the plane. All right, so we know the intersection point. Let's say the intersection point. Right, that is some x, y, z. So it's going to be 3 plus 3 times 1/8. Remember, we're just plugging 1/8 into the equation of the line here. Right? The y is just 1/8. And the z is minus 2 plus 4 times 1/8. All right, so now we just have to simplify that. All right. So everything in here should have a denominator of 8. So here, this bit is 3/8. 3 is equal to 24 over 8. So we have 27 over 8. 1/8 stays the same. And then this one, well, 4 times 1/8 is conveniently 1/2. And if we're going to take 1/2 and subtract 2, that's the same as taking 1/2 and subtracting 4/2. So we get -3/2. So this is the point of intersection. I guess we can also add in here, since we solved for t, this implies yes, they intersect. And here's where. So finding a intersection point kind of answers that former question, but it's nice to just sort of have written there that, yeah, they intersect, and now we're going to find the point.